Hi guys, today I'm going to explain to you how to do a certain kind of remainder problem that you might run into on the GMAT if you're doing well on the test. So here's an example of this question. If x is a positive integer, what is the remainder when 7 to the 12x plus 3 is divided by 5? Okay, so this problem might look a little intimidating, but actually it's a very systematic way of solving it. And so I'm going to show you the process of solving this kind of problem. So what you need to think about first is try to identify some pattern in the powers of 7. Okay, so let's see if we list out a few powers of 7, what we find. Okay, so let's say 7 to the 1 is 7, and the units digit of this number, units digit, okay, so units digit of this number is 7. So I just call it units d. And then if we take 7 squared, the units digit of 7 squared is actually 9, since 7 squared is 49. So I'll put the units digit up here as 9. And then 7 cubed, well actually we don't need to do 7 cubed to figure out the units digit. Think about if you're multiplying 49 by 7, then essentially the units digit of the final answer would be the units digit of 9 times 7. If you work this out, you will see that 9 times 7 is 63, and you would put a 3 down here. So that would have ended up being the units digit. So I'll just put 3 here. You can verify that if you did 49 times 7, you'd get a units digit of 3. And then same thing with 7 to the 4. If I want to find the units digit of 7 to the 4, well, I can do the same thing that I did before. Is if I multiplied 7 to the third by another 7, then essentially 7 to the third would have had a unit digit of 3. And so if I multiply that answer by 7, the units digit of the next number would be the units digit of 7 times 3. So 7 times 3 is 21, so this will have a units digit of 1. Again, you can verify that if you multiply the result of if you multiply 7 cubed by 7, the units digit will be 1. But essentially, every units digit can be generated by multiplying the previous unit digit by 7. And so 7 to the 5 would have had would be the last unit digit of 1 times 7 would give us a unit digit of 7 again. So you can see, and then the next number, 7 to the 6, would have so let me put 7 to the 5 here. The next number, 7 to the 6, if I multiply this unit digit of 7 by another 7, I'll get 49, which is again has a unit digit of 9. So the units digit repeat every 4 numbers. So every 4 powers of 7, you have a cycle 7931. The units digit go in a cycle 7931. So every even power of 7, every fourth power of 7 has a unit digit of 1. So I can say that 7 to the 8 will have a unit digit of 1, and 7 to the 12 will have a unit digit of 1. So let's look at our question here. They wanted us to figure out the unit digit of 7 to the 12x plus 3. Well, we just found that 7 to the 12 will have a unit digit of 1. 7 to the 12 times anything will also be a multiple of 4, so it'll also have a unit digit of 1. So 7 to the 12x will have a unit digit of 1. If you add, so we want to figure out the unit digit of 7 to the 12x plus 3 first. So if 7 to the 12x has a unit digit of 1, the next number after 7 to the 12x is 7 to the 12x plus 1. Okay, so 12x plus 1, 7 to the 12x plus 1 will have a unit digit of 7, and 7 to the 12x plus 2 will have a unit digit of 9. 7 to the 12x plus 3 will have a unit digit of 3. Okay, so we've identified the unit digit of 7 to the 12x plus 3. It's going to be 3. But the question said you need to add a 3 to this answer. Well, if you have a number whose unit digit is 3, if you add 3 to that number, like let's say there is a number that ends in a 3, if you're going to add 3 to it, the unit digit of the result will be 3 plus 3, 6. Okay, so I don't have space to write it, but it's 6. I'll just put it down here. So the unit digit of adding 3 to 7 to 12x plus 3 is 6. Then the question is, what's the remainder when you divide this number by 5? Well, a number that has a unit digit of 6, if you divide it by 5, the remainder will be 1. So that's your answer. It's going to be B. The remainder will be 1. So I just put remainder equal 1 here. And I'll just show you a more detailed solution here. So essentially, what I've shown here is that if you have if you generate the units that the powers of 7, you will get this cycle of unit digit 7931, and so 7 to the 12x plus 1 has a unit digit of 7, 7 to the 12x plus 2 has a unit digit of 9, 7 to the 12x plus 3 has a unit digit of 3. And so then, if 7 to the 12x plus 3 ends in a 3, then when you add a 3 to it, the unit digit of the answer will be 6. And any number that ends in a 6, when divided by 1, by 5, the remainder will be 1. So you can verify that if I have any number that ends in a 6, okay, if I have any number that ends in a 6, let me clear my screen here, that if I divide any number that ends in a 6 by 5, the remainder is 1. So for example, if I were to create some number, let's say 166, if I divide this by 5, okay, essentially this will have a remainder of 1, because obviously 165 is a multiple of 5. So any number that ends in a 6 is 1 greater than a multiple of 5, so I'll get a remainder of 1 if I were to do the division. I'm just not going to do it out, but you can see that if you divide this, you'd end up with a remainder of 1. So any number that ends in a 6, if you divide by 5, you get a remainder of 1. So that's the answer to your question. The answer here is B. And you can see that it didn't take very long for me to do this. Actually, I'm explaining this, so it takes a bit longer to explain it. But if you actually have to do it, if you know the process, you can do this in about a minute. All right, I hope you liked this video. If you like the video, like my video on YouTube, and subscribe to my channel. All right, I'll be posting more videos, so if you subscribe, you'll get notifications when I post a new video. All right, hope you enjoyed this, and have fun studying for the GMAT.